Welcome everyone to the H2O Hack. My name is Jasmine Muir. I am the Earth Observation Technical Lead at FrontierSI and the AquaWatch Capability Demonstrator Lead at SmartSat CRC. Today, I'm going to talk to you about quality assurance of satellite Earth observation data, an important aspect to consider for space-based technologies used in water management challenges across Australia. The upstream space sector, providing Earth observation images and derived analytics, is on the verge of liftoff. For the past several decades, it has been dominated by government missions and several prominent players in the private sector. Recent reductions in launch costs, satellite and sensor build costs, and the ability to deploy many small satellites in constellations from a single launch have resulted in a proliferation of new satellites with Earth observation sensors. Private industry, research and government plan to launch many more thousands of satellites with Earth observation sensors over the next several years. With these, many new satellites providing Earth observation data, there is also a proliferation of new derived products in the downstream Earth observation sector. With all of these new Earth observation satellite datasets, how does the end user determine if the data is fit for purpose? Currently, end users are faced with a somewhat daunting task of sifting through the various Earth observation data offerings to determine what data they should be using for their business case or research question. Quality information at the individual dataset is essential for establishing trust and enabling accurate use and reuse of data. When quality information is available, the data are perceived as worthy of use in decision-making environments. Calibration and Validation, or CalVal, provides quality assurance and are used to communicate the fitness of purpose to end users of the data. CalVal creates trust in satellite Earth observation data. Sensor calibration is the process of quantitatively defining an instrument's response to known and controlled signal inputs to characterize its performance. Validation is a process of assessing by independent means the quality of the data products derived from satellite observations. Calibration and validation activities cover all stages of the satellite lifecycle, that is pre-launch, in-space, post-launch, and ongoing during operations. Government-operated Earth observation missions, such as those from NASA and ESA, are characterized by having well-defined calibration and validation programs in place, creating rigorous quality assurance programs. Non-government missions typically perform calibration and validation. However, there is a wide variety of practice in this market segment, with room for better communication of quality assurance procedures with the end users of the data and derived products. In-space calibration is checking a satellite instrument's measurements against input signals from a known reference. This includes both calibration by imaging purpose-built targets, such as well-characterized colored shapes, such as these you see here, painted on the surface or on a structure for optical instruments, or a corner reflector with precisely known location, size, and geometry for radar instruments. In-space calibration also commonly includes vicarious calibration, which makes use of natural or artificial sites that are either very bright or very dark. The Earth Observation QA Testbed project is funded by the SmartSat CRC, and it has been completed by FrontierSI. We have investigated the current state of calibration and validation for commercial satellites in Earth observation. We've completed a series of one-to-one interviews in both upstream companies and downstream companies. Many of the issues reported in interviews related to data quality issues such as incorrect data types, units projection, or incomplete metadata to provide traceability. Difficulty comparing values across sensors and dates for satellite images were also noted. Off-the-shelf geometric location was not always good enough for use, and misalignment of individual bands in satellite images was noted as well. This project aims to build a prototype version of a tool that solves some of these QA challenges faced by end users. The aim is to help drive data uptake from end users by improving the ease of use of the data and building trust through transparent processing and documentation. This will enable them to know the data is fit for purpose. Our next steps, we have a workshop on the 21st of October this year to test these use cases that we've developed for a QA tool. We hope to build the tool, test it with end users, and then revise it based on their feedback. And then we hope to extend this to other validated use cases. At a high level, the Earth observation industry is seeking to develop the market for consumer products. The technical challenge is to ensure rigorous quality assurance is employed in a product development, and that it underpins a consumer trust that will drive the development of the market the industry seeks. Thanks for listening today, and I encourage you to think further about how you communicate the fitness for purpose of the solutions you develop as part of your H2O Hack project. Good luck and have a great hack.